We can perform basic operations with complex numbers, keeping in mind our rules for combining like terms as being important to combining those imaginary parts. So here we have two complex numbers that are being added, 7 plus 3i and 8 minus 4i. If it really helps you, you can go back to a pre-algebra, Algebra 1 understanding of these and imagine that there's ones in front of both of them. Otherwise, you can just jump right to the adding. 7 and 8 gives us 15. 3i plus negative 4i gives us negative 1i. As frustrating as it might be to get into the habit of putting that 1 there, it's not a bad idea to continue to do that because, again, with complex numbers, it's very important to identify the real and imaginary parts. We want to make sure we understand that the imaginary part of this is negative 1i. In our next example, we have subtraction. Again, if you want to consider those ones and use the distributive property, you can. Otherwise, you can just jump right to the subtraction. Negative 3 minus negative 6 is just positive 3. 4i minus negative 3i is plus 7i. And again, we have a real part of the complex number, and we have an imaginary part of the complex number. In our last example in this video, we have multiplication. This is going to be a little bit trickier and will definitely require our understanding of the distributive property to finish. So we're going to start with negative 8 times the second complex number minus I times the second complex number. Negative 16 minus 8i comes out of the first distribution. Negative 2i minus I squared comes out of the second. In a normal variable situation, we would think we were very close to being done. The two middle terms would combine to make negative 10i. I was thinking about a different variable. Negative 10i, followed by minus I squared as not having any like term. But because we know what I is supposed to represent, I is supposed to represent negative 1. That doesn't help me here, but it certainly will help me right there. Because if I is equal to square root of negative 1, then I squared is 2 of those factors, which gives me that I squared must equal 1. Negative 1. Because I is one of those square root of negative 1 factors, I squared is 2 of them. Square root of negative 1 times the square root of negative 1 is going to be negative 1, which is going to change this last line to negative 16 minus 10i minus negative 1. Simplifying the negative 16 and the minus negative 1 gives me negative 15 minus 10i. So while addition and subtraction did not have that extra consideration because at no point was the imaginary part being multiplied by the imaginary part creating an I squared, multiplication has this extra worry of what happens when you multiply I by itself. When you multiply I by itself, because it is a representation for a square root, you just get the radicand that was on the inside of those radicals. And because that happens, that I squared term disappears. Negative 1 takes its place, and it gets combined with the negative 16.